This meeting is being recorded.
For problem 13 in chapter 20, we're asked to draw a structure for each of these following compounds, A through D, which the names are given here. So in our first compound, the name given is dimethyl oxalate. So we should recognize that these are all carboxylic acid derivatives. So as a previous question, we always start with our carboxylic acid, or in this case, a dicarboxylic acid parent. So what I see here is oxalic acid, which is the dicarboxylic acid shown below. So if we were to remove these protons here and then replace with the two ester, or the two alkyl groups mentioned here, the dimethyl, we would create instead a diester. So that's what we see here, this dimethyl oxalate. And the name 8 at the end implies that we have the diesters here. Let's take a look at compound B, and the parent now is named as cyclopentane carboxylic acid. So that's the structure that we see over here. So once again, if we know that's our parent, in this case, when we have cyclopentane carboxylate, we know that we're going to end again with an ester, and our substituent instead of, or our alkyl group rather, instead of two methyl groups, now is going to be the phenyl group shown here. So again, we have our parent from our carboxylic acid, cyclopentane carboxylic acid. Instead, we have cyclopentane carboxylate, and then we add the phenyl. In structure C, we have now an amide that will be our final answer here. And we see that we have our parent from propionic acid, or we could think of this as propanoic acid as well. So we know that there's 1, 2, 3 carbons in our longest chain. And instead of the OH group over here, we're going to replace that with the N of our amide. And we can see that we have on that nitrogen in the amide portion of our functional group, we have a methyl substituent. So that's our alpha group over here. In our last compound, we have the same parent here of our carboxylic acid. We have propionic acid, which if we were to draw would look like this. So you can see where this propional, we change the ending to NYL, and then we add a chlorine substituent here where the hydroxyl group was. And we have our last compound, again from the parent propionic acid, propionyl chloride.